Okay, good afternoon. My name is Sumantro Sinha. I'm the co-founder and team leader of RocketCraft. Here's my partner and GNC lead, Hassan Chowdhury. This will be a short 5-minute presentation to give you an overview of who we are, what our vision is, how we're driving our rocket development, and a short glimpse into how we're going about doing that, then followed by, if you're looking to contribute something to a young company slash Centeo Challenge competitor, what you can do. So, starting off with just a quick snapshot of our company. So currently our team consists of 4 team members. Recent to me, he's responsible for mechanical design at Pfeiffer. He's doing helping build up our manufacturing base for constructing our rockets quickly. Moses Paulino, he's responsible for power systems engineering and maintenance at FP&O. He's doing the same for RocketCraft with the addition of a sensor integration. Hassan Chowdhury, he's our GNC lead. He works at MTN Satellite Communications. He's doing telemetry and guidance and control software for a rocket, and myself, I'm doing the aerodynamics, propulsion, and structural design for the rocket. Our advisors, we have 2. First is Joe Lee. He brings experience from the DCX program at McDonnell Douglas and been working on the recent Blue Origin rocket. He did the structural design for that and brings lessons learned from both companies to help us avoid mistakes that they did in the past. Craig Trent, he also worked on the DCX with McDonnell Douglas and now works for Orbital Sciences. He is helping us with our controls and guidance, and he also brings lessons learned. In terms of short overview of our financials, we've invested $8,000 from our pocket into this endeavor so far, which has resulting in the following unique technologies. First is a phase change heat shield for our re-entry capsule, followed by a surge aerodynamic control system for stabilizing the rocket following a catastrophic engine failure mid-flight, along with the emergency propellant dump system to lighten the weight to allow it to land after that failure. Then our control algorithm, ROSA, which stands for Recursive Orientation Sensing Algorithm, to allow the rocket to sense its position intelligently, ending with a wireless sensor grid to simplify the electronic connections to make it more resilient to unknown problems in flight. So here's some key statistics about RocketCraft. So for the rocket, we're aiming to get 5 kilos into a 600-kilometer circular orbit. These are aimed, and we're trying to get these statistics. We're not there yet. We're aiming to get a $5,000 per kilo cost with a 24-hour turnaround by drastically simplifying all of our systems, along with having fail-safe so that we can fly, fail, and still recover and learn from the experience without losing all the hardware. Also, these systems are there to reduce the amount of labor needed to actually operate and launch the rocket. So far, to get to those goals, we've built 5 rockets. However, we've not flown anyone yet because they haven't been flight ready yet. 5 rockets have mainly been to practice the various designs, putting it together and making sure they operate properly on the ground before we attempt flying them. However, hopefully in the next couple of weeks we'll have our first flight. So employees, as I said earlier, with 4 dedicated team members with 10 part-time volunteers. In terms of development, we've put in $8,000 with 2 patents pending, one in the heat shields and the other in the aerodynamic controls. Followed by 4 custom manufacturing tools like Interorbital. We are developing our manufacturing base from scratch because you don't have the money to buy the tools. So we've constructed a thermal chamber, shaker table, in the process of building a 3-axis CNC machine, and finally a vacuum forming table. So here's our basic philosophy for the rocket development. Basically, the way we see space is that we did a quick analysis of who the masters in each transportation medium are and how they became the leaders in those areas. And we found that the companies that became the true kings of that arena helped the general public truly capitalize and build in that arena on their own. We gave them the freedom to do so. So in the early 20th century, for land, Ford, a motor company, helped bring the automobile down to the common person. So the workers that are building the cars could actually afford to buy them and driving. In the 1930s, for air, Pan Am did the same, connecting continents and making Europe and Asia hours away instead of days and weeks. In the 1990s, cyberspace, Google helped us connect each other much more closely by making information accessible instead of easily accessible, and allowed people to use the internet to build and make it useful. And now in the future, Nova RocketCraft wants to do the same for space by making it easy for the general public, middle class, to be able to get into space, to be able to build infrastructure in orbit. So because of that, our vehicle will be reusable so that you can not only put stuff in space, but also bring it back and do it repeatedly. So now, Hassan Chaudhry, he'll go into a short view into how we're going about doing this.
Hey guys, we wanted to give you guys a bit of a glimpse. We couldn't take you to our facilities, so what we tried to do was we brought a little slideshow, and I'm just gonna talk through it very quickly. Our team, a lot of the times what we do is we do a lot of conceptual designs, and we do it right on the board, right before we implement anything. We rarely move forward without doing any, a lot of on the boards and discussions and everything before we go forward. Currently we're working at Florida International University's engineering campus, and through some student groups, we were able to actually get some space to actually, store some of our materials, and we rented a storage facility, storage container, to hold some of our tools and a lot of our anything we implement or we require. This is the machine shop we're working at currently. It has it does not have a CNC machine, but it does. We do have a lathe, vertical bandsaw, different mills, and it's available, open to us 24/7. We can go there almost at any time. Unless other students are working on it, we have these tools available to us to build anything we want to. A lot of our current progress is for anything that's very detailed oriented. We laser cut everything early on. We noticed that making it by hand, because we don't have access to CNC, takes a very long time and it's not very good quality. So what we're doing currently is basing everything off of 2D laser cut things. One example of this is a CNC machine that we're currently in the process of making. As you can see, it's not quite finished, but we estimate maybe 1 or 2 months we'll have this, and then we'll, after that we can actually go ahead and do custom geometries to whatever specifications we may have. This is currently the design that we have in mind for our rocket. It's a 2-stage orbital launch vehicle. The first stage, actually both stages will be, recoverable via parasails, and they will be guided back to inside the Earth. However, we are actually producing a very small version of this, and that's basically going to be our testing apparatus. And we actually we had difficulties actually manufacturing it. So what we did, we started practicing vacuum forming. As you can see here, very, very crude. This is, I think, was our first try ever. And then, we ultimately just ended up building our own heat chambers and a larger vacuum forming table with designs we've laser cut to actually make the shell, as you can see here. So, we're doing more and more complex things with every month. Every month it just gets more and more complex. Our tool base is getting built up. So as you can see here, we think we're doing a great job. Electronics, we're also in the process concurrently working on electronics for our booster stage. At the end of the presentation, we're going to be probably passing this around for you guys. We're using ARM-based embed processors. A lot of you guys, I know you guys are using Arduinos to do a lot of prototyping, but we're actually going with the embed systems. Gives us a lot of libraries available online for us to very easily implement our ideas. And we're always working towards making our testing. One you can see here is one of our concepts that we actually created in SolidWorks, and we actually were able to laser cut it, and you can see that we do all of our prototyping virtually and actually are able to implement our designs. This here actually is a device to actually separate our booster stage from our orbital stage. So this is a scaled down version of something we're testing currently. And this is the representation of our booster stage with the staging mechanism in place. And we will be passing the actual prototype around at the end of the presentation.
So yeah, if you can see, it looks very crude, and that's intentional. It's made to allow fast iterations, so we can, as we've learned this system by actually flying hardware, we can change out parts and get very rapid iterations, 1 day turnaround times on designs. So we can get maybe 7, 10 iterations in a week. And
ultra low cost.
Yeah, very, very low cost. This is basically Home Depot and Office Depot parts. So.
It's a good starting point, we think. We're also, at the same time, we're doing this, we're also actually doing a 1-to-1 scale of our booster stage made out of plywood. And this is for, the team to sort of get a physical understanding of what will the manufacturing take place, because we foresee our own cells actually manufacturing it, and actually once we build it, we have to actually assemble it also. So we actually are, there's a lot of things we've, realized and we've learned throughout actually, doing these assemblies. When we make these mini models, we're not just arbitrarily choosing certain things in the way that we're placing these things. We actually have, a feel for why, certain mistakes we might make.
And which dimensions are important to,
dimensions, all that stuff. Here's our one of our places that we do a lot of our testing at. They're basically a model jet club. They fly to approximately 500 feet, and we do all of our initial testing here. And they have FAA certification to certain altitudes.
Yeah, it's super remote, right next to the Everglades, so it's far away from the population base in South Florida.
This is one of our mini engines that we tested. Samancho actually did all the designs, and we actually were, this is quite a success. Ultimately, I think we're going to be using this for staging, perhaps. We're unsure as to exactly how we're going to be using these, but we're getting our hands dirty already with actual engine testing. Going through the process. So yes.
Also, we'll use this to heat test the heat shields. Get the proper heat fluxes, make sure it can survive the heat of reentry. However, this is, as if you guys have never tested engines, we knew the hard way. We learned the hard way. Do not do it in a populated area. They'll call down every kind of law enforcement on you, and you have to, tell them what it is that you're doing.
How many fire marshals did you say?
For those of you guys who don't know the story, we actually tested this around, we were very excited, we were around 1 a.m., 2 a.m. at FIU, and right about, a couple hundred yards away, there were some homes, and some people called 911 and said, oh, we're hearing some fire shots, people firing with guns or whatever. Within minutes, we had city police, county police, the fire department, so it was a big mess.
Yeah, they came in full gear and everything, so
yeah. It's hilarious. But, lessons learned.
We won't do that again.
Wow.
Safety and...
So are you guys out on probation now?
Yeah.
I'm surprised they let you leave the state.
So,
They didn't tell him.
Oh, even better.
So, and after doing a lot about template burns, we see that we're already doing some of the analysis. You can see that the actual ceramic actually melted on our spark on our ignition system and the spark plug. We actually are currently seeking anyone who wants to contribute to our team. If you're passionate about engineering, aerospace engineering, computer engineering, we're actively looking for people, talented people who want to contribute. If you possibly don't have the time, where maybe you have a lot of experience in aerospace, in re-entry, in spacecraft systems, in CubeSats, nanosats, manufacturing, we'd be very interested to hear from you, to learn anything from you guys. or maybe you want to be part of the project, you want to affiliate, or be affiliated in any way, university, individual, let us know. And of course, just like any of you guys, we're looking for any sort of monetary sponsorships or investments, as well as tools, secondhand tools. If you guys know anybody or have any of those facilities available, please let us know. And feel free to contact us, me or Cilantro, at any time. Visit our Facebook page. And
Any questions?
What
Any
is
questions?
the Facebook page?
Oh, it's Nova RocketCraft.
No, but not RocketCraft.
Yeah.
no, but
So any questions?
Lights, let's see. Oh, yeah.
Oh, yeah, sure. Okay, so yeah, pass this around, you can play with it. It's staging system. Electronics. It has a pitot tube, pressure sensor, accelerometer.
Doing it exactly the right way. People don't understand the value of prototyping with the full-size vehicle, even if it's out of plywood or cardboard, whatever it might be. You get a sense of how things fit.
Alignment issues,
Yeah.
you get to realize, and if we were to just do mini scales, small scales, and scale it up, we would find out later after investing the money and the energy and the time. So this is one of the ways that we feel that we can definitely come ahead without making the least amount of mistakes that we can.
Yes, so wasting the least amount of money possible on basically just building up the experience. So yeah, any questions?
Cool.
Thanks, guys.
Thank you.
Awesome, dude.
Go for it.
Yeah.
All right.